Hi guys, welcome back. We're gonna go over 6.1 Radian Measure. Now, I know this was not part of the syllabus, but I want to go over it because there was actually some confusion and some questions that were brought up um, on the previous couple of sections, and a couple of students were like, "Sir, I don't get it, sir. I'm getting the wrong answer. The answer I'm getting is not showing up." And the reason being is that when we were plugging this, so say I was asking something like, "Oops." Okay. Say I was asking something like tan of 30 degrees, right? And instead of getting the answer, people were getting some weird decimals, some like 0.11111, whatever. And the fact of the matter was this that when we went to our calculator, our mode was in radians and not in degrees. So when you get your calculators, your TI 84s, you want to press mode. You scroll down like two times, and then there's a radian and degree, and you want to go to degrees when you're dealing with degrees. But because there was this confusion, I wanted to talk about radian because this is another way of measuring um, in math and in trig. So um, so I'm gonna do my best at explaining this. Okay, so a radian. So this is what we have. Let's suppose we have a circle. Okay, we have a circle right here. The radius of the circle is 1. So the radius from here, from the point to the edge, is 1. Okay. Now, same goes for the terminal side. So we'll call this angle, like we have this angle right here. That's the initial side, and this is the terminal side. This is also 1, right? Because it falls along the edge of the circle, and we know from any center point to the edge is the radius, right? So this is 1, this is 1. So now we have this new degree right here. So let me highlight it so you guys can see it. This new degree. Now that degree, or I wouldn't say degree, that new angle theta is actually a radian. All right. Now, how do we know it's a radian? This is how we know it's a radian. A radian will always be that this arc length, the arc length, okay, is the same, which in this case is 1, as the radius. Okay. So 1. This is a measure of 1. This is a measure of 1. And this arc length is also a measure of 1. And because they're all ones, the initial side of the angle, the terminal side of the angle, and the arc length of the angle, they are all ones. This theta angle would be considered 1 radian. Okay, and then you're probably thinking to yourself, okay, that does not help me one bit. Okay, just hold on. Just I need everybody to get this idea that the initial side, terminal side, and arc length are all 1. Now, what we need to figure out is we already know. We already know this. We already know that when we go full circle, it's 360 degrees, right? So if we have our rotation going all the way around, from here would be 0 all the way around. This would also be 360, right? We know that. Well, in radians, we kind of need to know that. So if I was to make, let me use a different color. Okay, let's use blue. Okay. So if I was to make how many radians, so I'm actually getting into this, or how many arcs would it take to go all the way around? So we would have to kind of have maybe something like that, not drawn to scale as my buddy Joe would do it, right? We would come up with 6, 1, 2, 3, 4, 5, 6, and a little bit. Why would we come up with 6 and a little bit? Now, now my angles are not drawn at the best, but it comes back to something that we already know. We know that the circumference Let me hit this over here. We know that the circumference, I keep on pressing the little button right here, is 2 pi r, which is the radius. But what do we say that the radius and the arc length are? They're all the same. It's 1. So technically, we need 2 pi of these arc lengths, right? Of these 1 arc lengths. Well, what is 2 pi? Well, that's just 2 times roughly 3.14, which is this is 6.28, roughly, right? So it's 6, 1, 2, 3, 4, 5, 6 radians and just a little bit more, right? So that is the arc lengths around the circle. So we have 2 pi r of them. Now, this is important. Why is this important? Because if we don't have our our calculators in degree mode, our sine of 30 degrees is going to be way different. Because when you have it in radians, it's talking about sine of 30 radians as opposed to 30 degrees is what we want, right? Okay, this color is a little bit too light. I can barely see it. So sine of 30 degrees is way different from sine of 30 radians. Okay. So now we have to break it down. Now let's figure out how much each radian equals in degrees. But in order to do that, we kind of have to get some knowledge that we already know. Okay. So right now, we know we need 2 pi r, right? Radians. That's going to give us the full 360 degrees. So that means I could say that one full rotation is 2 pi r. Right? We know it's 360 degrees. And now in radians, we know it would be 2 pi radians, right? We need 2 pi of them. But what about half? Well, if I cut this in half, 360, if I cut 360 in half, that means I have to cut this one in half. So half and half would give me 180 degrees. These, the two will cancel, leaving me pi r. So that means half of a circle is just pi radians. So if we go back over here, so I drew my my angles wrong, but this should be 1, 2, 3, and a little bit more. So actually, it should have been like this, maybe like that, maybe like that. So we would have 1, 2, 3, and a little bit more. That 0.14. Okay. Okay, guys, I'm using a new tool called the XP pen. It's pretty nice, but I'm still struggling a little bit learning how to work the little trackpad. So give me a break. Okay. So back to what we were saying. So we know 360 degrees is 2 pi radians. Half of that is pi radians. So what would be a quarter? Well, a quarter is just half of half, right? So we could cut this in half. Cut this in half. And that would give us 90 degrees equals to pi radians over 2. Now, some people will write it like this. Pi over 2r. Whoops, you can't even see that. Pi over 2r. That's fine. You can put the r to the side. I like to do it like this as well. Doesn't matter. It's the same thing. So, oh, as you can see, I got my package. Um, what would be another? Ooh, I don't want you to see that yet. What would be another way to divide 360? So we did halves, right? We did divided by two, but there's multiple ways of doing this, right? There's multiple ways, and the reason why I want to get into this is because we're going to need to know 30 degrees, how much that is in radians. We're going to need to know 45 degrees. Oh, which we can do, right? Because that would just be half of half, right? That would be this half, the quarter, cut that in half. So what would that be? We could do that off the top of our head. We cut this in half, that makes it pi r over 4, right? We wouldn't want to know 60 degrees. Of course, 90 degrees, which we just found out. Probably 120 degrees, 180. We want to know all of these. We really do. Because the more we know, probably 315, 350. Because these are the most common degrees that always pop up, okay, in math problems, right? So we want to know this. So how else can we do this? How else can we divide 360? We just did it by halves, right? We did it by 2, 2, 2, 2. But there's other ways. There's multiple ways of doing this. Okay. So I want you to write right here. What other ways can we divide this so we could get um multiple radians? Okay. So you would just write something, write your ideas, or maybe show me your ideas, maybe draw a little table, kind of like what I did here. Um, Showing me how you got them. And I want you to take a picture of it, send it to me, and I'm going to give whoever does this, I'm going to give 5 bonus points on your test grade. Okay. So your everybody just took chapter 5 test. I'll give you 5 bonus points on that test grade if you fill this out, if you take a picture of this, and then you send it to me. Okay. What would be another way to divide 360 degrees for the radians or radians? Now, converting between degrees and radians, we could actually figure it out, right? So we have this 360 equals 2 pi r. Okay, so I'm gonna write that down right here. 360 equals to 2 pi r. Now, if I wanted to know exactly how much a radian is, I just solve for radian. So I divide by 2 pi, and this would be 180 over pi, which would give me the radian, right? Now, this would be 1 radian, okay? So 1 radian, if I do that in my calculator, I go 180 divided by 1 radian. So I go 180 divided by pi, and it gives me 57.29. We could put 29.6. And that'd be 29.6 degrees. So 1 radian equals roughly about 60 degrees, right? 57 degrees, okay? Now, if I want to convert from radians to degrees and degrees to radians, I have this little conversion chart. So this is kind of like a way to convert from whatever degrees they give you to a radian. Okay. So, and I should have done this in a different color because it all looks monotone, all black. But here it is, guys. So let me highlight. Whoops, I forgot I have to use the pen. So here it is. Bam, bam. I would highly recommend you have this highlighted, ready to rock and roll because I'm going to give you some questions like this on your chapter 6 test. Okay. I'm going to give you just simple uh, convert this degrees to radians, convert this radians to degrees. Boom. It'll probably just be 2 questions, one of each, but those are 2 gimme questions, right? So make sure you know how to convert them. Okay. So we know that 1 radian is 57.296 degrees. Now, why is this important? Well, this is important, especially when we get into the next part, the unit circle, because the unit circle does something for us, right? And when we're trying to find out the radians or the degrees, um, sometimes they don't give us the degrees. Sometimes they don't give us the radian. Sometimes they give us a coordinate, right? A coordinate point, and we have to figure out um, what are they talking about? At what point are they talking about? Right? Is it 1/2, and then square root of 3/2? What is they talk? What are they talking about? So right here, guys, I kind of this is the unit circle that most people will learn. A little tweak. I tweaked it a little bit to kind of go in my go in my flow of how I like to, I guess, understand it. So right here, guys, these I'm only gonna look at the top half. Okay, so let's just bear with me real quick. So looking at the top half right here, each one of these I guess this little sector in orange kind of go with each other. The oranges go with each other. This little sector would be considered the radian. Okay, so if I was to find this radian, this beta radian, it would be pi/6. Okay, so that would be my radians. Okay, now I could find that in degrees as well. Okay, so um, this right here, this angle, this angle beta would be 1/4 or 1 pi/4 radians. Okay, so each one of these is radians. All right, so I want you to kind of understand that. Now, where did all these numbers come from? Okay. So that's what we're going to get into right now. We're going to get into where did these numbers come from? And I'm gonna hopefully the way I am telling you, it's easy to understand and follow along. Okay, so what I really want to do right here is I kind of want to figure out where I'm getting all these numbers from, right? So I'm only going to look at the top half. So I'm going to look at from here up. Okay. So, what you're gonna notice is that you're gonna have a couple different numbers on a unit circle. So I'm first gonna go over the orange ones. Okay. So the orange ones, they're gonna look a little different from this one, but I hope that once you see why I wrote them like this, it's gonna make more sense when you look at the actual unit circle. Okay. So I make 6 sections, right? So I have 1/6. I have 2/6. I have 3/6, 4/6, 5/6, and 6/6. So if you notice, 1/6, if I was to do that, think of it in terms of degrees, 1/6 would be 30 degrees, right? So this right here, woo, why did I write 60? This right here would be my 30 degrees, okay? But what about 2/6? Well, 2/6, I could reduce this, can't I? What's 2/6? 2/6 is just actually 1/3. So what's 180/3? 60 degrees. So that means this angle, this one from here would be 60 degrees. Now this one right here is 3/6, which is 1/2, right? So that means it's 180 cut in half, which is 90 degrees. And we know that's 90 degrees, right? So we have this 90-degree angle, right? So what about 4/6? Well, 4/6 can actually also be reduced to 2/3, and that's how you're probably going to see it on the unit circle. You're going to see it simplified. But I like to show you this. I like to show my students this part because I like to tell them that it's these 6 little slithers, right? 6 sections, right? So you always want to remember 6. And once you do it on the top half, you kind of do it on the bottom half too. So you just kind of continue it. So if there's 6 on the top, there's going to be 6 on the bottom. So it kind of makes sense. So 6/6, which is just 1, which most of the time you'll just see this as pi, right? and then 7/6, 8/6, which this one will reduce to 4/3, 9/6, which you'll see as what? 3/2. Right? Yeah, 3/2. And then 10/6, which you'll see as 5/3 pi, right? I'm sorry, these all have that's a pi, by the way. Then 11/6, they won't reduce that one. And this one, they will reduce 12/6, would actually just be 2 pi, right? So it goes full circle, right? Now, that's not the only one that we have, right? So we have the 30 degrees. You start off by 30s because that's a good number you could divide 360 by, okay, by 6 or by 12, however you want to see it. But there's another one, right? It's the one that we did where we cut it in half. So what was 360 cut in half? Well, it was 180. So if I get 2 pi, cut it in half, well, that's like saying 4/4 or 2/2. But then I cut that in half and I get 90. And I cut that in half and I get 1/4, right? And then from this 1/4, I could just kind of build my my green lines out. So I have 1/4, 2/4, 3/4. This would be 4/4, 5/4, 6/4, which is the same as 3/2, 7/4, and then 8/4, which is the same as 12/6, or just I, right? So I wanted to go over this is because this unit circle, it's very important. So you're gonna know um, right away which ones you're gonna be using. So if you were to take a wild guess, what would this angle be? This 1/4 pi. Okay. So we already know it. We know that this was 90 and this 1/4 is half of that. So this is actually a 45-degree angle, right? So when you're dealing with the 45s, the 90s, the 135s, you know that you're dealing with these green ones right here. Okay. Dealing with the 30s, the 60s, the let's see, what would be that 120, 150, that would be these orange ones, right? So I just kind of want to go over that because later on, these are going to help you, especially with calculus. Um, these will help you. So it's good to know. What else did I write down here? Uh, now to find the degree measure of each, okay? So if I was to tell you what is 5 pi/6 in degrees, you should be able to figure that out. So we already know um, these first ones, right? So pi 1 pi/6 is actually 30 degrees. 1 pi/4 is 45 degrees. 2 pi/6 is 60 degrees. 3 pi/6 is 90 degrees. You should be able to know all of these like the back of your hand. So I'll let you guys do that. Okay. And here's the kicker. Here's what I was talking about. Um, you would need to find the coordinate of each ordered pair. So, okay, so what does that mean? Okay, so let me kind of erase this. Boom, look at that. Way easier. Okay, so what does that mean? So if this was an x-axis, right? I'm gonna try my best. And this is our y-axis. Green. Okay. I want to know this point. What point would this be in terms of coordinate? Ooh. And we could figure that out. We know that oh my god, this is a horrible triangle. Let me try to fix this. Okay. I wish there was like a way to just draw straight lines. We know this. Okay, so we need to know the y, and we need to know the, because we already know that this is our radius. So this is, let's do this in blue because the y is in blue. And we know that this is our radius r. So pi over 6. This is our degrees, right? So that gives us this degree measure, which is in this case, I keep on putting 60. It's 30 degrees. Okay. Uh, but what would it be? What would it be in terms of the coordinate? So I want you guys to find out all the coordinates of this unit circle, right? So you guys should get something like 1/2 square root of 3 over 2, or maybe you'll get square root of 3 over 2 and 1/2, or maybe you'll get uh, square root of 2. Actually, maybe you'll get 2 over square root of 2, right? And remember, you have to rationalize. So I want you to do that. So this is part of the other bonus problem. Okay. So I want you guys, and you guys should be taking notes. So this is going to be a way for me to make sure you're also taking notes. Is I gave you the radians, gave you the degrees for the most part, kind of give you all the hints. I want you to tell me each coordinate point. So you'll just kind of write it on the side right here. So you'll just kind of denote it like this and just tell me. So we have uh, pi over 4, give me the coordinate, and then you tell me the degree. So this is 45 degrees. Whoops, move it up a little bit. 45 degrees. Right here, 2 pi over 6, give me the coordinate, right? And then tell me the degrees, which this one was 60 degrees. Right here, we have 2 pi over 4. Give me the coordinate. And then this was 90 degrees. So this is kind of what I want to see on your paper. And this is going to be, in fact, I'll make this an additional bonus. So if you do the first one I said, and you do this one, I'll give you guys 10 points on your test. So, and if the 10 points puts you over 100, I'll save those points for chapter 6 test, okay? But you have a chance at 10 extra bonus points right here. So I want you to go find out all the coordinates for each one of these. So you'll have 12 total. And I already gave you a couple of the degrees, so you don't have all 12 to find out, but the degrees should be the easy part. And I want you to take a picture of this along with this bonus right here of explaining how to divide it, which I kind of already talked about it down here too, right? Another way of dividing it and figuring it out. And you guys will get 10 bonus points onto your test. Okay? So 10 bonus points is big, guys, especially on a test. All right. I'll see you guys later. I'll be posting this video shortly and we can go from there for next time.